Hello, Namaste. Myself Rohini Mirgu talking about univariate analysis using R. This video is divided into two parts. So this is part 1, univariate analysis using R. At the end of this video, you will be able to explore univariate analysis. You will be able to compute univariate frequencies and statistics using R Studio. Univariate. What is uni? Uni means one and variable indicates a variate indicates a variable. Univariate analysis is the form of analysis that involves a single variable. In the practical settings, univariate analysis means the analysis of a single variable or a column of the data set or the data table. What are the different univariate analysis? There are three types of univariate analysis. One is univariate frequencies, other is univariate statistics, third is univariate visualization. In the univariate frequencies, the frequencies can be calculated as the absolute frequencies or can be relative frequencies, and also there is a cumulative frequency, there is cumulative absolute frequency and cumulative relative cumulative frequency. And in the univariate statistics of the data set, we can find out minimum, maximum, average, median, mode. Median is same as the second quartile, and first quartile, which is also called as lower quartile, third quartile, which is also upper quartile. Then univariate visualizations. In the visualization, there can be a bar chart, pie chart, line chart, histogram, area chart, and the box plot. So number of other visualizations, number of other statistics are also there. As I am restricting this video for univariate analysis, only these many are mentioned here. As I am restricting my video for univariate analysis, I have shown only univariate statistics, univariate visualization and univariate frequencies. Univariate analysis examples in the real life are finding the average height of a country's mean from a sample, or finding the average salaries of the employees in a company, or another example can be finding the number of pets in a different households, or finding the heights of the students in a certain age group, finding the country's most frequent winning Olympics gold medal. For this we need to create a frequency bar chart, and understanding the income distribution of a country by analyzing the distribution's shape. The shape can be right skewed. If it is right skewed, one can indicate that there is unequal in society. These univariate analysis, that univariate frequency, univariate statistics, univariate visualization can be executed either in Python, in SQL, in R, in JavaScript, or can be in Scala also. But the very popular one in finance and in academia is R. R is a perfect language for data manipulation, for processing, visualization, as well as for statistical computing and machine learning. R refers to a programming language used for statistical computing environment, and R is a powerful and widely used language and environment for statistical computing and graphics. R provides wide variety of statistical and graphical techniques, including linear and non-linear modeling, time series analysis, classification, clustering, and many more. And R Studio. R Studio is an integrated development environment, which is IDE of R. It provides a user-friendly environment for writing, executing, and debugging the R code. R Studio offers various features such as code editing, debugging, data visualization, package management, etc. This makes it easier for users to work with R efficiently in the R Studio. What is R and what is R Studio? Can you reflect on this? So in summary, I can say R is the language, syntax used to write scripts and programs for statistical analysis in R, whereas R Studio is an IDE, integrated development environment, that provides a convenient environment for writing, executing, and managing the R codes. How to install R and R Studio? So for that, very simple steps are there. The R is a freeware software, so one can go for a CRAN website, cranrproject.org. One can click here and then can download R for the different platforms that you are using. Whichever platform you are using, I have installed R for Windows. Then click on install button of R for the first time and follow the steps, and R can be installed very easily. Once R is installed, one can go for this link for installing the R Studio and download the studio, download R Studio, follow the steps, and can install R and R Studio. If you want the detailed explanation, you can visit this link regarding the installation. So editor window where you can start with new R code, you can write the code, can run it. In R console you can execute the commands, and in workspace and history you can see the whatever executed in the console, that history can be seen here, and in the different variables that you have created, that can be seen in the workspace, their values can be seen in the workspace, and plots and files are available in the fourth window. R window will look like this. So once you install R window, this window will be observed. So let us start R Studio for univariate analysis. You need to click here. You can go for R 4.3.2, which I have installed here. It will show this window. And then I go to R Studio. R Studio will be opened like this here. This is the default view. The windows which I have shown are here. This is the console, R console. This is R editor. This is workspace. This is the plots and files. So here I can start my program, writing the program by opening on the clicking on the plus sign and R script, which will open the new file untitled. So this is the new R file where I can write the code for determining the frequencies. So let us start with univariate frequencies, in which I'll be finding out absolute, relative. Let us load the CSV file. D is equal to read.csv. This will read the CSV file with, into the bracket I need to put the file which is named as data, that I can take. So this will read the CSV file named data. Next, what I want to do is I want to find out the frequency variable which I can access. This is absolute frequency which I can find out, and table is the command with which I can access it, and D $weight will access the variable weight from the data, and I can print it. So you can see the frequency is printed here. The variable can be seen here. This is the complete table. In this weight WT which I am accessing here. So you can see I have read the CSV file. Absolute frequency can be plotted by using the table. Then I have printed the absolute frequency. The relative frequency. So relative frequency, I can give the name to the variable is equal. Instead of equal to, here the operator is this one, which can be given as relative frequency represented in percentage. So relative frequency can be represented as absolute frequency upon the sum of the absolute frequency into 100, and I can print relative frequency. And if I run this code, I can run partially also, so it shows me in percentage relative. For finding out the cumulative frequency, I can use the function CumSum. I can write the command like cumulative frequency as CumSum of absolute frequency. So this is absolute cumulative frequency. When I print, I can see the cumulative frequency here. You can see it's 1 plus 1. Again, I can write CumSum of relative frequency, and I can run the command. It will show me the cumulative relative frequency, and it is at the end it is 100. That means it's finally added all these percentages. As it is percentage, maximum it can go to 100. Now we'll try to find out the statistic, univariate statistics, minimum, maximum. Let us find out all the statistics. For that, what I have done is I have considered one variable w. This w variable, when I run this, it should be created here, it will contain only the weight column. So this weight column I am going to process. I am finding out min and max of this. So this you can see minimum of weight is min of w, and if I print, I can get minimum value from the weight. If you see, this is the weight here, and in that the minimum value seems to be 55. So it's not shown here, but if you want to see, you can click W here in the console. You can click on W here in the console. It's a capital word, and you can see all the weights values here. In this values, you can see the minimum value is 55. Similarly, this here I can execute the max value, I can run, I can see that the maximum is 115. I can also find out the, so mean is the function used for finding out the average. If you run, same way I can find out the quartiles, first quartile, second quartile, third quartile, which is at 25%, 50% and 75% respectively. For that the function used is quantile is the function used for this. If I run this, you can see that I can get Q1, which is at 25%, 67 is the value, at 50%, so it is 0.5 written here, and 0.75 for the 75%, these are the values. So these are the all quartiles which are at first, upper quartile, lower quartile, upper quartile, and middle one, which is also happens to be median of the samples. And altogether I can see all these values. If I run, the complete program will get executed, and I will get all the values such as the frequency, absolute frequency, relative frequency, cumulative, relative, cumulative, absolute. Also I get min, max, quartile, everything. But the same thing I can do with a single function like summary of the data. The data is D in my case. So if I just execute this single function, I get everything. So summary of D will give me, if you see in D, there are the friend, temperature, weight, height, gender and company. So all these are shown here. Friend, temperature, weight, height and company. Temperature, height and gender, height, these are the quantitative attributes. So we get the values of min, max and average only for quantitative attribute. So these are the quantitative attributes, and for that temperature, weight and height, we are getting min, max, first, second quartile, third quartile, median and mean. So these values can be displayed with a single function, which is, these are the references used for preparing this video. Thank you.